Hi everyone, this is Preeti Paudel. I'm a researcher at the National Renewable Energy Laboratory, and today I'm here to present on our paper titled EV Hosting Capacity Analysis on Distribution Grids. I'd like to thank my co-authors Sivani, Santosh, Deepak, and Jal for their contribution to the work and the paper. Starting with the background and introduction, recently there is an increasing trend in the adoption of electric vehicles as the electric vehicle technology is improving and advancing while the cost of battery energy storage is decreasing. So the increasing electric vehicle charging load on the electrical grid could be a challenge to the grid operation. Therefore, there is a need for studying the existing grid conditions as well as looking into the impact of uncoordinated electric vehicle chargings on the grid. In this regard, we have developed a hosting capacity tool which evaluates the electric vehicle hosting capacity of the existing distribution feeders. It uses the actual network considerations and provides high-level insights for the EV adoption. In addition, it also has the capability to estimate the different charging levels, including the extreme fast charging, which is around 300 kilowatt of charging power. Next, we move to the methodology and some results. In our approach, first we selected the performance parameters, the voltage and the thermal limits. So the hosting capacity will be determined by the voltage and thermal violation limits selected here. Some of the limits, especially the voltage limits, will also be selected or adjusted according to the scenario we have considered. There are three scenarios considered. First is the perfect feeder information. Second is the no secondary model available, considering that we have only modeled the primary of the network and their secondary part of the network is not there in the model. So in order to adjust for that, we adjust the voltage violation range to be 0.975 and 1.05 accordingly. Third scenario is to account for some uncertainties and assumptions. Next is the EV hosting capacity assessment, where we conduct the nodal hosting capacity. And also there is an extended analysis which shows the hosting capacity of each node for hosting the different levels of EV charging, including the extreme fast charging. For the simulation analysis, we modeled three real-world utility distribution feeders, and the result on the right is the result for feeder 1, which is the commercial and industrial feeder. The top plot shows the nodal hosting capacity for different nodes of the feeder 1, and the hosting capacity is limited by the voltage. Similarly, the bottom plot shows the hosting capacity limited by the thermal violations. For further detailed information, please refer to the paper. Similarly, we have more results here. The first row of the plots show the EV hosting capacity heat map, where we see that the first commercial and industrial feeder has higher hosting capacity than the second heavily residential feeder, while the third feeder is mostly industrial feeder and it has comparatively higher hosting capacity than the residential feeder, while comparatively less than the commercial and industrial feeder. And the lower row of the plots represent the number of extreme fast charging extreme fast chargers that each node can host. And here also the feeder 1, which is the commercial and industrial feeder, can host comparatively larger number of express chargers. So in conclusion, the EV hosting capacity varies between feeders depending on the existing network conditions. The commercial and industrial feeder has comparatively higher EV hosting capacity compared to the heavily residential feeders. As the future study, it would be interesting to look at the necessary upgrades required to accommodate the uncoordinated EV charging loads. Another interesting study would be to determine the system level EV hosting capacity, incorporating the coincidence of several EV charging at the same time. And another study could be screening the utility feeders to identify the feeders or the locations that are vulnerable to high EV charging loads. Thank you. For further detailed information, please refer to the paper and please feel free to contact me. Thank you.